Hi everybody! So in the previous videos, we talked about adding and subtracting fractions with the same and different denominator. But today we're going to be talking about comparing fractions with different denominators. Because let's say we have two fractions, 1 over 3 and 2 over 3. Which one do you think is greater? Well, obviously 2 over 3 is greater because they have the same denominator, but the numerator is greater. But what about when the denominators aren't the same? We can't exactly compare them when the denominators aren't the same. It's like trying to compare an apple to an orange. So that's what we'll dive into in this video. So to compare fractions with the same numerator but different denominators, I've prepared an inequality for us to use. Which one is greater? 1 over 2 or 1 over 4? Well, to visualize this, let's say we have two equal-sized pies. Now, one pie is cut into 2 pieces, and the other pie is cut into 4 pieces. So for the first pie, the fraction 1 over 2 implies that we ate one slice of the 2 slices in the pie. And this in the second pizza, the 1 over 4 implies that we ate one slice out of the 4 slices. So which piece do you think is bigger? This one or this one? Well, if you said the first one, you'd be correct. And notice how this pie's denominator is less. That's because when you cut a pie into less pieces, you get more pie in each piece, rather than this one, the second pie, where it was cut into 4 pieces instead of 2, and you got less pie with each slice. So remember, when you're comparing two denominators, and both of them have the same numerator but different denominators, the greater one is always the fraction with the smaller denominator, because 2 is smaller than 4. So now we're going to move on to comparing fractions with different denominators and different numerators. So I've made a few example inequalities for this situation too. The first one is, which one is greater, 2 over 4 or 1 over 6? Now, in some cases, if one fraction has a bigger denominator than the other fraction and a smaller numerator than the other fraction, then that usually means it's less. Because remember, if the numerator's lesser and it's the same denominator, then it's obviously going to be the less number. But now the denominator's bigger on the second fraction, which means you get less pie per piece. So 2 over 4 is the greater fraction. Okay, so now that we've dealt with easier inequalities, we're going to go to a more difficult inequality. So this is the problem that I am using. Which one's greater, 2 over 3 or 4 over 5? Well, let's visualize this with two same-sized squares, but one is cut into 3 pieces and the other is cut into 5 pieces. Now, 2 over 3 of a square with 3 pieces means that we're shading in 2 pieces of the 3 pieces. And same with the 5-piece square, so the second square. Since there's 4 in the numerator, that means we're shading 4 pieces of the 5 total pieces. Now, this one looks bigger, right? But let's prove it so that we make sure that we aren't imagining stuff. And how do you do that, you may ask? Well, remember what we did in our adding and subtracting fractions video? We made both of them have the same number of pieces, aka we took the number of rows in this square and made them into columns for the first square. So now this one has 3 by 5, 15 pieces. And then we do the same thing to the second square. We take the first square's rows and make them columns in the second square. So there's also 15 pieces in here now because 3 times 15 and 3 times 5 and 5 times 3 are the same thing. Now, let's count how many pieces total was shaded. For the first square, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 15 squares. And let's do it for the second square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 15 pieces. So what do you think is greater? 10 over 15 or 12 over 15? It's very obviously 12 over 15. So 4 over 5 is greater. And notice how we use the same method that we did while adding and subtracting fractions with different denominators. We took the second fraction's denominator, and we multiplied it by the numerator and denominator of the first fraction, because 2 times 5 is 10, and 3 times 5 is 15. And we did the same thing with the second fraction. We took the denominator of the first fraction and multiplied it by the numerator and the denominator of the second fraction, giving us 4 times 3 is 12 and 5 times 3 is 15. So whenever you want to compare two fractions that with different denominators that aren't obvious, just make them both have the same denominator. Anyways, thanks for watching my video. I hope this made comparing fractions a little less tricky for you. If you liked my video, don't forget to like, comment, and subscribe. I would really appreciate that. See you in the next video.